Everybody, I'm going to take a little bit of time and explain to you how you should fill out the physical constant sheet found in either the lab supplement available at the bookstore, or if you go to Professor Sherlock's site, he's got a constant or a link to print out a Word version of this that you can print off and use. Now, I have imported this guy into a way that I can draw on it, but nonetheless, let's go over how this works. Okay, so here's what you're going to do. You're going to take all that information from the general procedure, and for each compound that you find in the general procedure, and this is how they build off of each other, you're going to write those compounds here. Okay, so this is going to be 1 compound, 2 compound, 3 compound, 4 compounds. Okay, whether it's a reactant, a product, a solvent, or a drying agent, you're going to do that. Okay, so I'll put a solvent here, and then I'll put a drying agent here. That way we have it all figured out. Now for lab 1, the simple distillation of three mixtures, you're going to have 6 compounds here. You're going to fill in the experiment up here. Okay, and so you've now gone through and put all the compounds here. Okay, what you're going to do is you're either going to calculate or look up the molar weight for each of the compounds. So that's something you're going to look up for each of the compounds, or again calculate. So if you have a compound that is, I don't know, cyclohexanol, you can calculate that by knowing that this is C6H11OH and adding that up, or you can look it up. Okay, now the amount used, that's where it gets a little tricky. Now this isn't grams per mole, it's not density or the grams per milliliter. This should be written as either grams or moles, or milliliters, I'm sorry, if I could talk English good. Because if it's a liquid, you're going to add milliliters to it, and if it's a solid, you're going to add the compound in grams. So this is just the primary thing. So you're going to have to know whether this is a solid or a liquid. Now, what you end up doing is going back to the lab, and typically it'll tell you, for example, like, hey, you're going to use 6 milliliters of this. Okay, if you have to do a calculation, like in this lab, you have to do a calculation for how many, I'm sorry, you don't have to do a calculation, you're going to do 155 milliliters. You can just fill that in. So maybe, and again, black, so the 6 milliliters, 155 milliliters. Okay, now in this column you have to do a calculation. Very rarely do we give you the number of moles for each of those in the lab. We just calculate it. So you need to, on a separate sheet of paper, in a separate page in your lab notebook, write all the calculations that are referred to in this journal. And if you look, a lot of times you'll see a preliminary calculation thing on the Prelab. So here's the preliminary calculations. That's to fill out the physical constant sheet. So now we go here. Okay, and so we're going to calculate these. These are all going to be calculated numbers. Okay, now the theory in used. This is always an issue for students, but I will tell you, when you do a reaction, let's say we're doing cyclohexanol reacts to form cyclohexanone. Okay, in theory, what is the ratio? For every one of these, how many of those are we forming? So for every one of these, we make one of those. So let's say that's what this is. Our theory is 1 to 1. The used column is from how much is actually calculated, is from here. Let's say after we calculate it, this ends up being 12 moles, and this actually ends up being 6 moles. What is the used ratio? Well, the used ratio is actually 2 to 1, but in theory it should be 1 to 1, which means we have a large excess of whatever this compound is. Okay, so now these things, melting point, boiling point, density, solubility, and index of refraction, this stands for index of refraction, index of refraction. Those can all be looked up in some sort of reliable resource. You can use the CRC, you can use some chemical companies online. So there's all sorts of things that you can use to find it out, but make sure that you look up the correct value, because that's going to be important. You're going to have to refer to these as you're writing up the analysis. The last thing is this CHP number. So you've filled out the chemical hazards and precautions, and you have numbered all your compounds in the CHP. So you're going to carry this over here. So this is going to be, let's say it's experiment 9. Okay, this is going to be 9-1, 9-2. Okay. Now, lastly, you have any solvents or drying agents. In this case, you don't have to calculate the number of moles, the mole ratio for these things, because those are only being used to purify the compounds and will vary greatly in how much you use. It would be great if you filled this information out, and especially this information out, but you don't have to calculate anything for it, okay? Because from lab to lab, from person to person, group to group, it's going to change, okay? So that is how you fill out a physical constant sheet and do the pre-calculations for the physical constants part of your pre-lab write-up. Make sure you go back and you know how to convert to moles for this thing, just FYI. Okay, have a great time.